Okay, so today we're starting a new chapter. It is triangle trigonometry, and today we're going to look at part of the law of sines. So before we jump in, we need to talk about something very important. We are leaving right triangle land. Triangles we deal with in chapter 7 are like most triangles in the real world. They are what's called an oblique triangle or a not right triangle. So that's a triangle without a right angle. They are known as oblique. So when we were back in geometry, we talked about triangles being congruent, and we had 3 ways of telling if triangles were congruent. We could do side angle side congruency, we could do angle side angle congruency, and we could do side 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 congruency. And those 3 congruencies are kind of going to dictate which way or which formula we use in this chapter to find the missing pieces of the triangle. So down here, there's 4 cases, and these cases are not numbered this way in like mathematics in general. This is just the 4 ways that it happens, and your books numbered them case 1, case 2, case 3, case 4. So please don't leave this class and say, oh, it's a case 1 triangle. That's not how the real world mathematics calls it. We would know that as a side angle angle or an angle side angle case. So in this section in particular and the next section, case 1 and case 2 are going to be law of sines. Case 3 and case 4 are going to be what we call, we'll learn more about in section 7.3, law of cosines. This doozy right here, the side-side angle, may lead to more than one triangle, which we're going to talk more about in the next section. And just one thing to note, we never have angle, angle, angle congruency because all triangles add up to 180 degrees. So angle, angle, angle congruency does not exist because it is not enough to relate that the ratios of my sides were somehow related to a fellow triangle. So before we jump in, let's talk about the law of sines a little bit. I'm going to highly encourage you to read through this entire proof. So I'm going to write that in here. You can go ahead and pause the video. Oops. So go ahead, pause the video, and please read through this proof. And there's one part in particular I just want to note to you because we're going to use it in a later section. Okay, now that you've had a chance to read through this, there's one little part I just want to highlight, just to keep in the back of your mind. It's this height formula. We're going to use this more in section 6.2, but just hold on to that. So now that you read through this, we have what's called the law of sines. The law of sines is a set of ratios that says any side over sine of that angle, or the corresponding angle, is equal to the ratio of any other side over the sine of that side's corresponding angle. So 2 things to note. Number 1, upper and lowercase letters really matter. We always use lowercase letters for the sides, and we use capital letters for the angles. The second thing, I'm going to go down here and write. Because this is a set of ratios, I can invert or flip over all the ratios. So a corresponding or equivalent version of the law of sines you might see somewhere is sine of angle A over side A equals sine of angle B over side B equals sine of angle C over side C. So if you flip one fraction, you can flip all of them and then make another version of the law of sines. So let's go use the law of sines in mathematical practice so you can see how it works. If you don't have a calculator, please go grab one. You're definitely going to need one. So our first two examples are side-side angle and angle-side angle cases, and they want us to solve for the missing parts of a triangle. And this is something that I have been saying to you since day one, but just beware. When you're calculating things, if you have to go grab something in the problem to use to calculate another missing item, you are better off using something they gave you as opposed to something that you calculated and rounded, because that rounding can introduce more error throughout all the things that you found. So the first thing I'm going to do is I'm going to draw a triangle, and this will make more sense in the next section, but I always go find the angle they gave me. It's an acute angle, so I'm going to draw a little small acute angle, and out of habit, I always have been taught to draw it like this. So here's the beginning of my triangle. This in here is angle A, which they tell me is 32 degrees. And if that's angle A, then across from angle A must be side A, which they tell me is 42.9 centimeters. Close off my triangle. And then because it's named angle ABC and we read from left to right, I'm just going to go up the triangle and call this one up here B. And we know that B equals 81.8 degrees, which makes this little b down here. And then this is capital letter C and lowercase c. So if I want to find all the missing parts of the triangle, let's start with capital letter C first. The angles of a triangle always add up to 180. So to find capital letter C, I can take 180 degrees and subtract away the 32 that I have from angle A and the 81.8 degrees I have from angle B, and that will result me in having what angle C is. Angle C, if you type that in and calculate it, should be 66.2 degrees. So there's one piece I'm missing. I was missing 3. I found one of them. Now let's use the law of sines. I have an oblique triangle, which means I have a triangle that does not have a right or a 90-degree angle. And I'm going to find some missing pieces. So I have a complete ratio, capital letter A, angle A, and side A. And having that complete ratio right here and right here is a key giveaway that you can use the law of sines, which you'll want to keep in your mind when we get through the chapter, because you're going to have to differentiate between when to use law of sines and when to use law of cosines. And if I'm being completely honest with you, I never learned that it was in the cases of side-side angle or angle-side angle. What I did learn was if I have a complete ratio, A and A, B and B, or C and C, that I could use law of sines. I have a complete ratio, definitely using law of sines. So for this one, I'm going to say that 42.9 over sine of 32 degrees is going to equal, I might as well finish off C, so little c over sine of 66.2 degrees. This right here is the bare minimum work that I expect you to write on your paper. Bare minimum, absolute bare minimum. I would like it if you wrote one more step, but that is the absolute bare minimum. I'm going to go ahead and I'm going to cross multiply and then divide. So I'm going to get 42.9 times sine of 66.2 degrees divided by sine of 32 degrees equals C. So C, oops, that's still a highlighter, sorry. Oh, man. Oh, I don't think I can erase that now. Let's see if I can undo it. There we go, highlighter gone. Try again. So I can do C equals 42.9 sine of 66.2 degrees over sine of 32 degrees. Make sure your calculator's in degrees, please, please, please. And when you type this in, you should get that letter C is 74.1 centimeters. 2 things to note. Number 1, label your answers, please. Number 2, all of the numbers given in the problem have 3 sig figs, so I rounded it to 74.1 because 3 sig figs. Okay, I'm left with, I found big C, little c. All I gotta find now is little b. I'm going to go back and use the same ratio because these are numbers they gave me to start with. And since they're numbers they gave me to start with, I don't want to use any part of C, because if I miscalculated any part of C, then it's going to introduce another error somewhere in my problem. So go back to what they gave us. So 42.9 over sine of 32 degrees is going to equal side B over sine of angle B, which is 81.8 degrees. Again, very bare minimum. I would much like it if you wrote B equals 42.9 sine of 81.8 degrees over sine of 32 degrees. And when you do this through decimal places, you should get 80.1 centimeters. I'm going to say this one more time. You have to show me the bare minimum amount of work. I would like it if you showed more than that, but I'm not going to require you to. But this is a calculator-heavy section and a couple of sections for that fact. So if you just click, 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 and have no work to turn in, or no work to show on your homework or your tests or your quiz, then you're going to lose credit. So please ensure you are showing the bare minimum amount of work at least. In the next problem, they're so nice. They give you a picture. Be aware that not all problems come with pictures, but this one does. It says an engineer wants to measure the distance across a river, so it really just wants this letter A right here. And it says that he determines an angle C, that's angle C right there, 112.9 degrees, and that angle A right here is the 31.1 degrees, and side B is 347.6 feet. Find the distance of A. So I need a complete ratio, which I don't have yet. So since they gave me side B, I probably need to find angle B so that I have a complete ratio. So big angle B is going to equal 180 because 180 degrees in a triangle minus the angles they gave me, which were 112.9 and 31.1 degrees. This results in angle B equaling 36 degrees. Now I have a complete ratio. So let's go ahead and do this. I'm going to have sine of 36, and that was angle B. And on top I have side B, which is 347.6. Equals, I want to find little a, so little a goes up here, and I need to use then capital letter or angle A, which is 31.1 degrees. Bare minimum amount of work I must be shown. I would much like the next step. A equals 347.6 sine of 31 degrees, all divided by sine of 36 degrees. A is going to equal 305.5 feet, 4 sig figs, so I rounded to one decimal place for 4 sig figs. That's what is all given across the problem. Okay, so quick little review. Yeah, it didn't go away. I know how much you loved this before, but it's back. So bearings. Bearings did not go away, guys. So bearings. First thing, bearing has a synonym. So if it says a bearing or a course, that's a synonym. So beware of either word. And a bearing, in general, starts at north and rotates clockwise. So this one, for example, started at north and went 220 degrees. So one quadrant is 90, 2 quadrants is 180. I still have to go a little bit more, in fact, 40 more, ending right there. Another way to say this exact same thing is to look at just from right here to here. This is called south. This was 40 degrees towards west, which is what we have written over here. So you start at the first letter, the first direction, north, south, east, west. This one said start at south, go this distance, 40 degrees, towards the other letter, resulting in the exact same location. So that's bearings in a nutshell. Now we're going to use those. I know, you're going to draw a picture, for the next problem. So take a second, pause the video, just read through the problem. Okay, now that you read the problem, let's just go piece by piece. Just piece by piece. I'm going to underline some important stuff. So there are 2 ranger stations on an east-west line, like this. And they say later on that they're called Station A and Station B. So I'm going to start down here. Here's Station A. go over some distance. Actually, I don't want to go too far and run out of room to work. Go over some distance. Here's station B. East-west means side to side, so I drew them side to side, and this distance is 110 miles. It says that there's a fire, a fire, located at a bearing of north 42 degrees east from the western station A. So A is known as the western station, which makes sense because it is further to the west or to the left. So I'm going to draw my little compass thing like this. Bearings start at north and rotate clockwise. This one says start at north and go 42 degrees towards east. So I start at north, I'm going to go 42 degrees towards east, which is that direction, and draw my line up. So this piece in here is 42 degrees, which results on the inside piece being 48 degrees, because that's supposed to be a right angle, even though I can't draw. Then I have station B, and from station B, it says that you start at north and go 15 degrees towards east. No judging, can't draw. So this piece in here is 15 degrees. Let me extend my red line a little bit. So here's my fire. I know that this piece right here is 90 because it's a right angle. So this whole piece altogether is 105 degrees because 90 plus 15 is 105. And they want to know how far is the fire from the western station, which this thing over here I'm going to call little b, only because this is called angle B or station B. So that's B. And if this one is A, then this side over here is called A. And this means this is called angle C. We'll call this little distance right here C. So I want to find B. Well, I don't have a complete ratio yet. I need to find B. B over sine of 105 degrees, but I need a complete ratio. And I'm going to guess I have to find angle C because the only side I happen to know is little side C. So to find angle C down here, C is equal to 180 degrees minus, this is the piece inside the triangle, 48, minus the green 105 inside my triangle, which is going to result in 27 degrees. So now I can say that 110 miles over sine of 27 degrees, B will equal 110 sine of 105 degrees divided by sine of 27 degrees. And it says, read please guys, don't mess up. It says the nearest 10 miles. So when you type this in, you're going to round to not the tenths, but the tens place. 230 miles. So law of sines is not so hard. It involves reading, which I know is not your favorite, but you can do it. I know you can do it, and you will do it because you want to get a good grade because you are very smart. I know you can do this. And then a simple cross multiply, butterfly, bat and ball, whichever way you like to deal with proportions. So this section has one more little piece to it. I missed a page, sorry. It's finding the area of a triangle, and it's got a little caveat to it. So you've always found the area of the triangle by using the formula that they list at the top of the page. Area equals 1/2 base times height. This formula right here. And that's because every time in geometry that we have asked you to find the area of the triangle, we have so nicely done this right here. We've dropped the height down for you and told you what the height was so that you could find the area. Well, we're not going to be nice anymore, I guess, is the nicest way to put it. We are not going to give you h. You can find h, my friends, you can. So I'm going to use a second picture to show you how to find h. So we can drop the height down like this. This side over here is called h. They've labeled this angle A. So angle A is an angle I know. And if you look at angle A compared to h is the opposite, and C right here is my hypotenuse. So if I'm going to do sine of big A, it would equal my opposite h over C, my hypotenuse. And I can move that C over, so C sine big A equals h. So if I go over here for a second, instead of calling it h, we actually find the height and just plug it in. Now, please don't walk around saying that the height of a triangle is C sine A. C sine A. It's not C sine A. It is whatever that side was, sine the angle that you were given. And so the way that I remember this is a couple things. Number one, you have to have an included angle. Included means it belongs or it goes with you. And what I'm saying is this has to be with or in between things. So if I know B and C, my included angle here is capital letter A. Let me say that one more time. If I know side B and side C, then I must have angle A, because that is my included angle, or my angle between us. And if you notice, I said all the letters. I said B, C, and then A. So the way that I remember all the versions of this formula is the following. It's 1/2 side, another side, and then it's sine of the remaining letter. And here's what I mean. If you look at the first version, it says B, C, sine A. The next one says A, B. I'm missing letter C, sine C. The last one says A, C, sine B. So you have to have all the letters in the formula. And they're all arbitrary, just 1/2 side, sine the included angle. So let's try. Oops. So on the next page, it says, for example, 4, find the area of the given triangle. And look, this is exactly what it means to be an included angle. It is in between them, in between. So a couple things. I want to talk about this included angle. This angle is B. So let's talk about B for a second. Angle B is equal to 55 degrees and 10 minutes, which is 10 over 60. And we add those together. So that's going to result in a decimal, which is 55.1, and then 6 repeating forever. We don't want to round up front. It's just not a good idea. So you can use your calculator. And if you do 10 over 60 and get the decimal, and then do plus 55, and tell your calculator to take whatever decimal it gives you and turn it into a fraction, it will tell you without rounding a single thing that this is the same thing as 331 over 6 degrees. So now I don't have to round anything. So now I can do my area formula. Area equals 1/2 side, which I'm going to call 42 is the first side. My second side I will call my 34. And then sine of your included angle, which we're not going to round, 331 over 6 degrees. Make sure your calculation degrees. And then type that in. Your problem, all your numbers in this problem have 3 sig figs. So you should get an area of 586. Don't forget your label. And it's not just feet, it's feet squared, because it was an area problem. Not so bad. The next one also not so bad, but I'm going to own it up front. Super tedious because they don't give you everything you need. You don't have 2 sides. You have 1 side, so you got to find a side so that you have an included angle so you can do this. So I'm going to go ahead and I'm going to find side A, but first I want to do my little trick again with the angles. This angle right here is 24, and if you do 40 divided by 60, it reduces to 4 over 6, which is 2 over 3. So this is 24 and 2/3. So if you type 2/3 plus 24 in the calculator, it's going to give you, this is 74, and then turn it to a fraction, 74 over 3 degrees. Similarly over here, this is 52 degrees plus 2/3 of a degree, which is the same thing as 158 over 3 degrees. And now I don't have to do any rounding to find a big angle B, because I need a complete ratio. I need a complete ratio so I can do law of sines, so I can find the missing side A. Such a tedious problem with lots of steps. Big angle B is going to equal 180 minus the 74 over 3 minus the 158 over 3, which should result in, I think it's 102.3 repeating, but as a fraction, it's 308 over 3 degrees. This big angle B up here, 308 over 3 degrees. Okay, I had to find big B so I can have a complete ratio. So now I have a complete ratio of 27.3 over sine of 308 over 3 degrees. if you don't like my fractions, you go ahead, you do your decimals. I'm just trying not to round to introduce any more error in the problem. This is going to equal, I think I'm going to do A, just because alphabetical order, why not? Little a over sine of, what was this one, 74 over 3 degrees. That's the bare minimum. So little a equals 27.3 sine of 74 over 3 degrees over sine of 308 over 3 degrees equals about 11.6775. I think I'm safe at 4 decimals only because all the problems I have only have 3 sig figs, which for me would be 1 decimal place because of my 11. So I'm going to hold on to that. And then I'm going to do my area formula, which is what they asked me to find at the beginning. Area equals 1/2. If I use side A, 11.6775. And then the other side they gave me was B, which is 27.3. Then my included angle is C, so sine of 158 over 3 degrees. Make sure your calculator's in degrees. 3 sig figs. So, pipe it in. You should get 127. This was in centimeters, so centimeters squared. There's your final answer. A little bit tedious as far as typing in and numbers, but a relatively straightforward section.